Hello and welcome to Education at SSBJ Online Video Tutorials. We are here with a fresh chapter number 6, Combustion and Flame. So in this we are going to study the meaning of combustion, then the structure of flame, types of combustion, and how can we control combustion. First of all, what do we mean by combustion? We all have seen when we lit a candle, it burns with the flame. You go near the flame, you feel the heat which comes out of the flame. It is so with the case of any kind of burning. For example, when you put a fire to the wood burns and you find heat is coming out. And so as the paper, right? So all these together we call that this is the process of burning, right? What actually happens during burning? We shall understand the process of burning. Burning is also can be called as combustion. Both are almost same, and combustion involves a chemical reaction. So combustion is a chemical process. Now why combustion is a chemical process and what is chemical process? Whenever two substances react and forms a different substance, then that reaction is a chemical reaction, right? Chemical reaction. Now combustion is such a process which brings out a chemical reaction. And what happens during combustion? It is mainly a carbon, in majority of the times, combines with oxygen and gives carbon dioxide. But it need not be compulsorily carbon, right? In the case of wood, it is generally a carbon. Now, when other materials, even in the case of paper, it's a carbon. When you burn other material, then other products will form. And that is why we call it as a chemical process. So combustion is a chemical process. Point to be noted. Right? Then, second point which is very important, during combustion, it is a substance, let's say substance A or substance B or substance C, they all react with oxygen, right? So combustion is a process where substance reacts with oxygen. The third important point is that combustion is a process where you get heat out. It gives heat, and therefore you can combine these 3 points together, 3 important points together. Combustion is a chemical process which involves substance to react with oxygen and gives out heat. So the definition of combustion will be: combustion is a chemical process in which substance react with oxygen to give heat, called combustion. Now remember, these points are very important whenever you write this definition for the exam. It's a chemical process. It reacts with the oxygen and it gives out heat, right? It gives out sometimes a light also, but it need not be compulsorily. So in this case it gives out light, right? And also heat. But sometimes there are some examples where there is a combustion going on and it gives out heat but not light. We shall talk about this in future videos, right? So if you, when you write this definition, remember that you have to underline these words which are very important. Now these substances, for example, here it's a paper, this is wood, and here it's a wax. These substances which can combine with the oxygen and give heat are called combustible substances. Not all objects are combustible. If you talk about glass and try to burn it, it will not burn. It will not combine with oxygen and give heat. Okay, you take a stone, it cannot combine with the oxygen or burn itself. So these are the ones which are non-combustible, whereas the substances that undergo combustion are called combustible substances. For example, a coal, right? So this is a coal, or even the charcoal. We all have seen they burn and give out heat and also light. So they are combustible. What are remaining examples? Wood is a combustible substance. Can you recall some more examples? Petrol. Petrol catches fire rapidly. So it's a combustible substance. We all are using LPG gas, liquid petroleum gas. Okay, that's a combustible substance. Now if you look at this, this is a solid combustible substance. Here this is also solid, whereas this is liquid, right? And this is the gas. Okay, when it comes out of the cylinder, it is in the form of gas, right? So fuel may be a solid, it can be a liquid, or it can be a gas. Okay, as I said that it need not be compulsory that it should give a light. Sometimes some combustible substances combines with oxygen, gives out heat and light, or we can say they glow, and that glow is called flame, right? We call this particular thing as a flame. Now there are some materials which we will take up here. They are right in front of your screen, and then we can divide these substances into combustible, and rest of all those are non-combustible. We all know that wood burns, we can put fire to the wood, and that's why it is combustible. We all use wood, okay, to get heat. A paper catches fire and it gives heat. So there is a possibility of combining with oxygen as well as to give heat and light. So this is also combustible. Iron nails. We have not seen iron nails burning. Kerosene oil. We have seen kerosene oil burns, and that is combustible. Stone piece. It doesn't burn. Straw catches fire, and therefore it is combustible. All of us have seen charcoal burning, combustible. Matchstick is combustible. And what about the remaining ones, such as iron nail, stone piece and glass? They are non-combustible, right? So we have a substance, some are combustible and some are non-combustible. Well, coming back to a combustion again, we know now that combustion requires oxygen, And how do we say and how do we prove that combustion requires oxygen? Simple demonstration. Keep your candle, lit it, let the flame glow. Okay, then take a container, let's say beaker, right, particularly of glass, so that we can watch that flame and keep over it. Ensure that no air goes inside from here. So you can take a help of one bathtub and put some water over it so that no oxygen will go enter. Right? What happens? Right? In the previous case, this burns because it requires oxygen. And where is oxygen? Oxygen is everywhere here. Air contains oxygen. So this is using oxygen to burn, and then it gives out heat, and therefore we call this process as combustion. Now let us stop the supply of oxygen. So what we do, we keep a container over it in such a way that no oxygen is possible to get inside now. Now whatever oxygen which is there will be consumed, because this continuously requires oxygen. So that will be consumed, and a stage will come, all the oxygen gets over, and that is the time the candle gets off. And that is why whenever there is a fire accident takes place, the first thing we should do is cut off the supply of oxygen. And how do you do that? For example, if a person is caught in this fire accident and he is wearing a cloth which has caught fire and it's burning, then the first thing you should do is cover him with another cloth in such a way that no oxygen is available to get inside and support combustion. So first thing what we have to do to control combustion and to stop combustion, we should stop supply of oxygen. What we have learnt now is that oxygen is very important for burning. But is only oxygen important? Does a matchstick burn by itself? How does it burn? What exactly we do when we try to burn this matchstick? We take a box and then rub it over this portion, right? And then it burns. And why we do that? We know that when we rub this over a rough surface, due to friction, heat is produced, right? Again, suppose if you take a dry wooden stick and try to burn, will it burn suddenly? It takes some time. After a while it starts burning. That means in the previous case, when we see, we require little heat to burn. The temperature should come up. For particular temperature it starts burning. Already we have seen we require oxygen, and the second point is we require temperature to burn. And how do we get this temperature? We have to rub this over a surface, and because of friction, temperature rises. In the same way, if you try to burn a wooden stick with the help of a fire, for some time it takes the heat and the temperature will rise. After that, it combines with oxygen and then it burns. right? So therefore, we should remember that there are two things we require. One is oxygen and second is temperature. Do we have the same temperature for all the substances to burn? Different substances catch fire at different temperature. For example, if you take a wood, it requires minimum 220 degrees centigrade to get fire, to catch fire. Or LPG, liquid petroleum gas, it requires 410 to 580 degrees centigrade to get into the flame. What about petrol? Petrol requires around 280 degrees centigrade. These are the minimum temperature, or we can call a lowest temperature, which require these substances to burn. Oxygen is there in the air, but other than oxygen, we require lowest temperature. Right? How much ever oxygen you supply, but unless petrol reaches 280 degrees centigrade or LPG reaches around 410 to 580 degrees centigrade, that will not catch fire. In the same way, a charcoal or coal will burn approximately about 580 degrees centigrade. Right? A paper requires around 218 to 246 degrees centigrade. In the same way, hydrogen 536, sulfur you see, sulfur is around 200 degrees centigrade. Therefore, these are the lowest temperature, right, at which the different substance, which are shown on the screen, and that lowest temperature at which substance catches fire is called ignition temperature. Remember this point, this is point to be noted. What is ignition temperature? The lowest temperature at which a substance catches fire is called ignition temperature. Right? So what we have understood? We have understood the meaning of combustion. And what is a combustion? Combustion is a chemical process where the substance combines with oxygen and gives out heat and sometimes light also. Okay, then we have seen what do you mean by ignition temperature. The lowest temperature at which substance catch fire is called ignition temperature. Okay, now let's have some more information. In short, let me complete that. When we talk about this matchstick, in olden days, matchsticks were actually made up of sulfur, but now it's not. Okay, for the safety purpose, it is made of antimony trisulfide and potassium chloride. Okay, and now you must have seen a box, and on that box, this particular portion, it has some chemicals, which is a mixture of powder glass. Okay, powdered glass and red phosphorus. P is the symbol of that. So once we rub this matchstick, okay, the head of the matchstick is a mixture of antimony trisulfide and potassium chlorate. Right? When we rub this over this surface, again, which is a mixture of a powdered glass and red phosphorus. And why red phosphorus? Because it is less danger. It doesn't suddenly catch fire. Right? So what we do? We rub it over this surface. Antimony trisulfide also has a low ignition temperature. Okay? Low ignition temperature. And what does it mean? It means that it catches fire for very less temperature when there is a oxygen, just like a phosphorus. Right? Now when we rub this, red phosphorus gets converted into white phosphorus, and during this process, heat is given out, and that heat helps to raise the temperature of this antimony trisulfide, and then it burns into flame. That's how the matchstick works.